All right, so now I'm going to do a few of these assignments, but before I do the assignments, just to get you started on it, we went up through conditional probability in the textbook, and then we stopped before it talks about additional stuff after that, including like independent events and multiplication law related to conditional probability, and then also we didn't get into Bayes' theorem, and I find that that's too complicated for this class. So those are like the last couple of pages of the chapter. We're not going to do those. And if you have, but please read them. Please try to, make the best sense of them that you can. And if you come across problems here in the homework, do your best with them. And that's just the way it goes. So if I could adjust the homework to not have that stuff in there, I wouldn't have it in there. But yeah, don't sweat it. Don't sweat knowing that stuff. Do your best to understand it. Do your best to solve any problems that come up around it. But don't worry about it. You learned enough in this chapter. All right, so here, and I grade on a curve at the end of the semester just to make sure that it accounts for this. So now we're going to go into chapter 4 assignment here, and we'll do a moment of that. And I'm going to pause this video while I load everything up. All right, so here's the first one. An experiment has 3 steps, so 3 outcomes possible for the first step, 2 outcomes possible for the second step, and 4 outcomes possible for the third step. How many experimental outcomes exist for the entire experiment? That would be, it would be 3 for the first, 2 for the second, and 4 for the third. So 3 times 2 times 4. So 3 times 2 is 6, times 4 is 24. 6 times 24, 6 times 4 is 24. And I'm going to check my work, and yay, got it correct. So we're going to go to the next one. How many permutations of 3 items can be selected from a group of 6? So how many permutations of 3 items can be selected from a group of 6? So we're looking at combinations versus permutations, and permutations order matters. And we're talking about factorial here. And so I could come back to these notes, and maybe I'll link to these notes in our Canvas. I'll link to these notes so you'll have them here in modules. So I'll just link to all these notes. So here I'm going to go through, and the problem that we're doing now, I'm going to come over here and I'm going to go to this problem, and we're looking for permutations. So I'm going to go Control F here, Control F, and search for permutations. And so here's the first instance of permutations, the second instance in this. And so permutations is n factorial all over n minus r, where n is the total number of items and r is the selection out of that total number. So here we have 1, 2, 3, 4, 5, 6 items. So how many permutations of 3 items can be selected from a group of 6? 3 items from a group of 6 is going to be 6 factorial all over 6 minus 3, so 3 factorial. So 6 factorial over 3 factorial. I'm going to come back over here and launch a new sheet. So I guess, do we have factorials in this one? We don't. So I'm going to come back here. And really, I thought I had promoted, sheet 5. Oh, here we go. And did we do factorials? Yeah, here we go. So I'm just going to do another one right here. And actually, you know what? Working on the one we have will refresh our minds about what we already did. So here I'm going to do, I'll do over here, I'll just put a little divider in, make this like, a light gray, and then just narrow it down. And then we're going to have 6 factorial, and we're going to have 3 factorial. And we'll do here is equal to fact, and it's going to be 6. And then here it's equal to fact, and it's going to be 3. And so then we're going to have that one divided by this one. And 720 divided by 6 is 120. So we'll put in 120 here. And then use the letters A, B, C, D to identify the items, list each of the permutations of items B, D, and F. So use the letters A, B, C, D, E, F, and F to identify the items and list each of the permutations of items B, B, D, and F. So each of the permutations of letters B, D, and F. So permutations of B, D, and F will be BDF, and I don't know why we have these up here. BDF, and then we have, so BDF, let's just think about this here. So BDF is going to be, it'll be 3. BDF will be 3, and so that'll be 3 factorial. And then each of the permutations, I'm not quite sure what they're asking there. But you could always do it this way. Check my work. And they liked both of those. So there's 1, 2, 3, 4, 5, 6. And so if I just kind of like think, you know, the permutations of BDF. I got to think about that for a second. Hold on. I know what I'll do. So here I'm going to get to the snipping tool. So I'll launch this and go to snipping tool, and do a new, and then snip this. Boom. And I'm going to just take that picture, and then I'm going to save it. So I'll go to the disk icon, which is right here, and I'll save this to my downloads, and we'll call this temp. And so that's been saved. And then I'm going to come over here to ChatGPT. I'll say, can you please explain the attached? And then I'll go back over here, and I'm going to downloads, and I want to go to temp and drop that there. And it uploads, and let's see what ChatGPT has to say about it. I'll pause the video while, oh, here we go. The image you provide is asking how many permutations of 3 items can be selected from a group of 6, and then lists each of the permutations for a specific set of items. Permutations of 3 items from 6, you have 6 items, A, B, C, D, E, F, and you want to find out how many different ways you can arrange 3 of these items. Since the order matters in permutations, the formula for permutations is n factorial n minus r. N is the total number of items, 6 in this case. R is the number of items to arrange, 3 in this case. So how many permutations of 3 items can be selected from a group of 6? And we get 120, okay? So there are 120 different permutations. Using specific permutations, the second part of the image asks to list each of the permutations for the specific items B, D, and F. For 3 items, the number of permutations is 3 factorial, which equals 6. So it's 3 factorial, I guess, for number of permutations for 3 items. It's not like up here, it was asking us for how many permutations of 3 items from a group of 6, right? From a group of 6, how many permutations of 3 items? It's just 3 items. It's still a little bit confusing to me. It's kind of confusing the way that's being asked. I don't totally understand it. So learn something new a little bit here. So for 3 items, the permutations of 3 items is 3 times 2 times 1, which is 6, and the listed permutations are BD are those. This correctly represents all possible arrangements of the 3 letters B, D, and F. 120 permutations is the total number of ways to arrange any 3 items out of 6. And 6 permutations are specific to the set B, D, F, as they are the only possible ways to arrange those 3 items. Exercise demonstrates the use of permutations when order of items is significant. All right, so for the next one, we'll go on to the next one. We'll hit next here. Boom. And for the next one, decision makers subjectively assign the following probabilities to the 4 outcomes of an experiment. Right here they are. So outcome 1, I kind of want to say event 1 is 0.1, event 2 is 0.15, event 3 is 0.4, and event 4 is 0.2. Are these probability assignments valid? Explain. So, you know, decision makers assign probabilities to the 4 outcomes of an experiment. So the sample space, the experiment, these are the 4 outcomes. Like the probability all has to add up to 1. So do these add up to 1? That's 6. That's 75. This is 85. So this is no. They are greater than or equal to 0, but do not sum up to 1. So that's the answer right there. And we can check the work. And then we'll go to the next one. And here, a CBS News, New York Times poll of 1,000 adults asked the question, do you think global warming will have impact on you during your lifetime? Consider the responses by age group shown below. Yes, no, age. What is the probability that respondent 18 to 29 years of age thinks that global warming will not have an impact during his or her lifetime? To 4 decimals. So 18 to 29 not, 18 to 29 not, we have 131. And what is the probability that a respondent, 1829, thinks that global warming will not have an impact during his or her lifetime? So if you're 18 to 29, right, what is the probability that a respondent 18 to 29 thinks global warming will not have an impact? So how many respondents were 18 to 29? We have 267, so 131 out of 267. If you're 18 to 29 and we ask you, and you know what's the probability, you're going to say no. So we're going to do 131 divided by 265, 267. So equal to 131 divided by 267. And we're going to say it's 49.0. Well, here, let's just copy that number. So we could copy this, and then we could do a paste special, values only. And now that it's values, we could click in there, and it's going to be 0.49063. And it's to 4 decimals, so we'll just do that right there. And we'll come back over here, and we'll do 0.4906. What's the probability the respondent 30 plus years thinks that global warming will not have an impact during his or her lifetime? So that's going to be all of those numbers. Let's just get all these guys here. Control C, and then come here, and we'll do Control Shift V. That worked. And this just needs to come over, so we'll just grab this and drag that over. Sometimes it comes in funky. All right, so we can sum this up. We're going to sum that up, and we get that. And why didn't that like it? Let's do this again. So we'll sum this up, and we want to sum up those figures there. And then we're going to do this one, no, divided by all of the total 30 plus year olds. And then we'll copy that, Control C, and we'll paste it here, paste special as values only. And we'll click in there to get that, and we'll do, it's these 4 numbers there. So the probability, if you're 1829, the probability is that you'll say no, it's not going to have an impact, is 0.4906, and if you're over 30, it's 0.5893. For a randomly selected respondent, what is the probability the respondent answers yes to 3 decimals? So randomly selected respondent, what's the probability that they say yes? So we have 1,000 adults, and randomly selected, the yes will be here, sum that up, and we'll add those two, and then we're going to divide that by 1,000, so we'll say this is equal to that, divided by 1, 2, 3, and so the probability that you'll say yes is 0.427, so we'll come back over here and do 0.4270, and based on the survey, does there appear to be a difference between ages 18 and 29 and 30 plus regarding concern over global warming? Yeah, you know, like these people think no, these people think yes. These, you know, this amount thinks no impact, this amount thinks no impact, and this amount thinks yes. Yeah, it appears that what did it appear like? Younger respondents are more likely to think it's going to have an impact. So older respondents are less concerned about global warming being a threat in their lifetime than our youngers. Yep, and it appears that older respondents are more concerned. No, older respondents are less concerned. They're saying no impact. Older respondents and younger respondents are mostly unsure. There we go. We're going to do that. And we're going to check my work and see what I got wrong. What do we get? What is the probability? So here, to solve this, we could do this. And this is really what I want you to see. This is like one of the most important things I want you to see is like, how do you solve problems? And we're going to go new, and we're going to go like this, and we're just going to grab all that, and then copy it, and we're going to save it right there, and we're going to save it to temp. There we go. And then we're going to come back over here, and we're going to upload that. So we're going to grab that and drop it here. And why did I get that one question wrong? Can you show me how to figure that out correctly? You are amazing, by the way. Here we go. here we go. Satellite radio. Understanding the problem. You're asked to find the probability that a respondent aged 30 plus years thinks that global warming will not have an impact during their lifetime. The data is provided in a table showing responses for 2 age groups. Data provided 18 to 29, 30 plus. Calculating the probability. So I think it should be like the probability that they said no should be this over all of this, right? That will not have an impact 30. So what was the question? Is it like, what is the probability the respondent thinks that global warming will not have an impact? So here, no impact is right. Consider the responses. Do you think global warming will have an impact during your lifetime? No, will not have an impact. Should be 432 over all of that. Is that what we got going over here? 432 over all of that. So 432 all over that, 0.5895. Oh, I didn't round, 0.5895. There we go. And now I'm going to check my work. And I'm not sure. It doesn't like that. 0.5895. So that's approximately equal to 0.5895. The correct probability should be 0.5895, but the answer you provide is 0.5893. Discrepancy likely arose from a rounding error. So I'm just going to copy this again and put this in here once more like that and check my work, and it's not going to like that. And so we'll try 5894 and see what it does with that, and see if that's like, check my work. Hey, it likes 0.5894. So if I go back and I look at this, like it should be 0.589, and then right here, 0.589, this rounds up that to 4. So it's interesting, like ChatGPT gave me 5, so, sometimes you just gotta massage it. I'm ready to go to the next one. So here we go to the next one. But I hope like that gives you an example of using ChatGPT to do your homework. By going through these, you start to gain a little bit more experience. And use ChatGPT when you get stuck to problem solve. So that's a little bit of doing the homework. Hope you enjoyed that. Have a great day wherever you are, whatever you're doing. Have a great day. Have a great day. I mean it. Look for what's good. Look for what's positive. Count your blessings. I know those are cliches. They're hackneyed. They're trite, but they're also true. And it's all too easy to go through life with subtle contentions and subtle complaints about, not having this or not having that. Partly that's the way capitalism's geared. They need to sell you stuff. That's capitalism. And to sell you stuff, they need to make you discontent. Because if you're content, you're not a good consumer. You're not buying stuff. But if you're discontent, if you're dissatisfied, if you feel deficient, insufficient, right? Then you're ready to be a good consumer. And so there's a lot of powerful forces geared towards making you discontent. So you'll be a consumer and you'll buy stuff. But you have to consciously recognize that. And when you recognize it, you could counter it. And you could start to cultivate an attitude of gratitude. And you could start to look around and count your blessings for everything that you've been given. So we saw that at the Gapminder website, that we're living in the best time to ever live in, and that we've never been more fortunate as humans, and we live in an incredible country in terms of health and wealth and opportunity, and you have the opportunity to go to school. And yeah, life could be a lot of work. It was a lot of work probably when our ancestors were hunters and gatherers, and they had all those uncertainties, and they didn't have antibiotics or neosporin and they died from infections, and they lived to like 30 if they were lucky, and they had to hunt and gather and deal with wild beasts in the darkness of night, and it's a lot of work now. You got to learn some crazy stuff about statistics and get a degree and get another degree, but eventually you do it and try to have fun along the way and be grateful for everything you've already been given. So hope you have a great day, and look for all the things that are great in your life. Like find a couple things and start telling it to people, because for too long in my life I had those subtle complaints and subtle contentions, and and sometimes they were more than subtle. So just take a moment and be grateful for everything. All right, have a great day.